What type of a segment is ST?
Mid-segment.
A mid-segment. And what do we know about a mid-segment?
Half of the third side.
It is half of the third side. So if I want to find ST, and right now they're telling me that ST is M, I need to be able to write an equation. So you could say that M is 1/2 of whatever's on the third side, which is 30. That's one way of doing it. Or you could say that 2 of those M's give you the 30. Either one would work. Can you take the bat off, please? If you do it the first way, what's half of 30?
15.
15. If you do it the blue way and you divide by 2, what's 30 divided by 2? 15. Now yes, the one on the test was a little bit more complex because it wasn't just one number and one term, but there's another one coming up later that's just like that. It's going to be like the one we have on the test. Find the measure of ST is 15. And then the teacher asks, oh, are there any questions? So if you would have questions, then you would say something. Are these triangles congruent? And explain your reasoning.
Yes.
Okay, well let's see. What information are they giving us?
That Q is negative.
What information are they giving us?
Q and T are congruent.
Angle.
Are at the same
The measure of angle Q is equal to the measure of angle T.
R is congruent to U.
Well, we don't know yet that R is congruent to U. We'd have to find U first. And the measure of angle U plus 92 plus 39 would be equal to 180. So the measure of angle U, what is this, 141? Measure of angle U plus 141 is equal to 180 minus 141 minus 141. Measure of angle U is 39. So, did I do that wrong in my head? Yeah, I did that wrong. Hold on, that can't be. It can't be 141.
It's 131.
It's 131? Okay, that makes more sense. Yeah, 131. So then minus 131.
It's 49.
Yeah, that does give you 49. So measure of angle U is equal to the measure of angle R, which would have to then mean, this is actually called something called third angle theorem. That says that measure of angle S would then have to be measured equal to measure of angle B. But now back to the original question. Are those triangles congruent?
Yes. Yes.
No.
Yes, they're congruent.
Why? Prove it.
Because all their angles are
triangles.
So, and you guys learned a congruency shortcut for triangles known as angle, angle, angle? Bazi, can you sit in your seat, please? What are the congruency shortcuts?
side.
Side, side, side. Side, angle, side. Angle, angle, side, angle, and then you might have also learned hypotenuse leg, but that's really considered a type of side, angle, side. Alright, do any of those say angle, angle, angle?
Nope.
No. Now, what you might have learned, and this is before I got here, this was actually taught out of sequence. This should have been taught later, but here we taught it sooner. There is something called angle, angle, but that's not a shortcut for congruency. What is that a shortcut for? I was told that you were taught this before I got here. For similarity. We're going to actually review similarity again after the midterm, but I was told that this is something that you went over before I got here. Triangle similarity? No. No, Glenn?
No.
Okay, well, I'll bring that up in the meeting tomorrow. See, students say they've never seen. Anyways, are they congruent? it isn't that it's not yes, it isn't that it's not no, we don't have enough information. It could be congruent. It could be, because in order to be congruent, all the angles would have to have a corresponding angle that's congruent, and it does. We just don't know enough information. So the answer would here be would something be along the lines of not enough information. There is enough information to prove similarity, but not enough. They'd have to give us at least some information about a side. We'd have to know that a pair of corresponding sides at least were congruent. Ooh. Here's one on that. Did you guys do dilations? Because they have us doing dilations on the schedule also after midterm, but and it says review on it.
We did it in 8th grade.
8th grade? No, but I'm saying, like, did you do it this year?
Yeah.
I'm hoping it's not the first time, but this will be on the midterm, so let's do this anyways. So AB is a segment with A at -2.5 and B is at -4.1, and it's dilated by a scale factor of 3, and has a center of dilation at -1.2. So first graph the two segments, and then what are the coordinates of A prime, B prime? So let's see, -2.5 is up here, this is A, and -4.1 is here, and that's B, and then these are connected with a segment. Our center of dilation is going to be -1.2. What are the coordinates of AB, and then compare? Okay, so this is a big thing right here. As far as the amount of work that you have to do, the center of dilation, when it's not the origin, it gives you a lot more work. There's a lot more stuff you have to do. The way they taught this at the school I was at before, I don't know, they used the same. Did you hear that, SRA?
No.
Subtract, rule, and then add. Every time, for the adding and subtracting, you're doing that with the center of dilation. When you do the rule, that's the actual transformation that you're doing. So, alright, let's do A first. Let's find out where A prime is going to be. What A are we starting at? What's the A that we're starting at? Sorry, let me rephrase, I'm wording that poorly. What is the X of the A that we're starting at?
-2.
Was that a negative? I can't see, I covered it up.
Yes.
It is a negative? Okay, good. So I'm going to write -2. But then I'm going to subtract the center of dilation. What is the X of the center of dilation? Yeah, and if I subtract -1, that's the same thing as adding 1. Comma. What is the Y of the A that we're starting at? The Y of the A that we're starting at, the pre-image. Yeah, it is 5. And again, we're going to subtract the center of dilation. What is the Y of the center? 2. So we're going to go -2. Okay, so for the X's, now -2 plus 1 is -1. But now we need to apply the rule. When you apply a rule for dilations, that involves multiplication. You multiply by the scale factor. So what am I going to do with that -1? I'm going to multiply by a scale factor of -3. What the negative does is it's also going to flip it. Comma, what's 5 minus 2? 3. And then times the scale factor, which is -3. So if you're following at home, this was the subtraction. Now I'm doing the rule. Negative 1 times negative 3 is? It is 3. And then the last thing I have to do is add back the center. What was the x of the center of dilation? The x of the center behind. Adding a negative is the same as subtracting, so minus 1. What is 3 times negative 3?
9.
Negative 9. And then I'm going to add back the center of dilation. What's the y of the center? 2. So once all is said and done, my A prime is at 2, comma negative 7. So when I plot this, 1, 2, 1, 2, 3, 4, 5, 6, 7 is going to be A prime. Let me try to fit B prime. I made this part too big. For B prime. Here. Better yet. Why don't you guys do B prime? The same way I did A prime. Get the B that you started at. First subtract the coordinates in the center. Then apply the rule, which is going to be times negative 3. And then add back the center. And then we'll do it together. Sean, see question?
Wasn't the A supposed to be in the other quadrant?
Because it's 2.
Say that again?
It's supposed to be in the other quadrant because it's positive 2.
Was it, did I plot the A wrong?
Yes, you put it in negative 2, not positive.
It's positive 2.
Oh, yeah, that's right.
We're talking about A prime.
A prime on the bottom.
Yeah, it's supposed to be positive.
Oh, 2 negative 7. Thank you. I went negative 2. Thank you. 1, 2, 3, 4, 5, 6, 7.
Okay.
There you go. But everything else you agree with, right? Okay. So now find B prime. Raise your hand when you got it. Yeah, you got it, Jair? What'd you get?
I'm at 8, 5.
Yeah, I did the same thing in my head. So the starting, for B, the starting x is negative 4. We're going to subtract the center. The center of x is negative 1. Subtracting a negative is the same as adding. So negative 4 plus 1. The starting y for B is 1. And then if you subtract the center, 1 minus 2. So we get a negative 3, negative 1. Oops. Let's go ahead and do that. So I get negative 3 first for x, and then I'm going to apply the rule, which is times the negative 3. I get a negative 1 for y, then I'm going to apply the rule, which is times negative 3. I'm running out of space, so I'll just come back up here and then say that for the last step, negative 3 times negative 3 is 9. And then I'm going to add back the center. So plus a negative 1 is the same as minus 1. And then we're at 3. Negative 1, negative 3 is 3. And then add back the 2. So yeah, Jair was right. 8, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So compare the two. What can you conclude about the two segments? Okay. What can you conclude about the two segments? What happened to this? What happened to the? Huh? Yeah, they look parallel, but that's not.
I mean, segment those.
Yeah, that's fine. It looks like they would be parallel, but that's not like. What did we do?
You got to
made it bigger.
There you go. All right, so that'll be the first thing. Yeah, it's called an enlargement. Okay, and it was enlarged by a factor of 3. So talking about things you did in middle school, if you were to use distance formula to measure the segments, the distance of A prime B prime should be 3 times bigger. Whatever you get for AB, A prime B prime should be 3 times bigger.
I got my old test.
Oh, okay.
My guys.
All right, thank you.
Thank you. Sure, coach.
Another thing to notice how the scale factor was negative. If you heard me kind of slip it in there, what did the negative scale factor cause to occur?
3 times away from the original.
I kind of like mumbled it out when I was doing it. I was like kind of talking to myself. Huh? Yeah, the fact that the scale factor was 3 causes an enlargement 3 times. If I measure the distance between if I were to measure how long AB is and then how long A prime B prime is, A prime B prime would be 3 times bigger. But in addition to the scale factor being 3, there's also that negative there. And when in the middle of doing it, I kind of mumbled out what that negative was going to cause. Who said it? Somebody? A flip. Cause a flip. Look at AB. What was on top? A. What was on the bottom? B. Look at A prime B prime. What's on top? B prime, and then A prime is on the bottom. So the way you would write for B, if you compare them, A prime B prime is 3 times bigger, and a vertical flip also occurred. One last little nugget about dilations. If you ever want to know what the center of dilation is, sometimes they'll just give you like a diagram, and they'll ask you what the center of dilation is. If you connect the pre-image with the image, so if you connect A with A prime and B with B prime, where do they intersect? At the center of dilation. Wherever they intersect will be the center of dilation. I'm hoping that this won't. These are some of the tougher things that we've done this year, and some of you said that you haven't even done it yet. So I'm hoping that doesn't show up too much on the midterm. Just long. Okay, find Mn if M is between L and N. What do you think we should do here? What do you think would be a good strategy to take here? I'm going to find Mn, but what do you think would be a good strategy to use to help me? Yeah, I draw a picture. And I wouldn't worry too much about it being like drawn to scale, but if M is between L and N, I would draw L, I would draw N, and then somewhere in between I would draw M. And then Lm is 2x plus 1, Mn is 6x, and then the entire thing is 81. Now let's see if we can use this to write an equation. I cannot find Mn until I know what x is. Well, give me an equation I can use to find x.
2x plus 1 equals 6x.
2x plus 1
equals 6x.
No, you don't know that because you don't know. Nowhere does it say that M is in the middle. It says it's in between, doesn't say it's in the middle.
Plus 6x equals 16.
Plus, I do not know that these are the same. They never told me that those are the same. Just because a point is in between doesn't mean it's bisecting. It doesn't mean it's cutting it in half. But all I do know is that together, if I put these together plus the extra 6x, then I would get 81. That I do know. Add the x's, so we get 8x plus 1 is equal to 81, minus 1 minus 1, 8x equals 10. Sorry, I'm getting ahead of myself. It's 80, and then then once you divide by 8, you get 10. Some of you made this mistake on a different type of problem, but some of you made this mistake on the test yesterday. I got x, but they weren't asking me for x. What were they asking me for? Yeah, mn. So
60.
mn would be 6 times 10, which is 60. If they were to also ask you for ln, could you quickly find ln without having to substitute?
21.
It'd be 21, sure, because if you know that mn is 60, what's left over is 21. Subtract. Or you could, yeah, you could plug in the 10. 2 times 10 plus 1 is 21, but you could just also subtract. Oh, no, I didn't take a 10. Ooh. All right, Paige. I included this one in. I know that you have not covered this one yet. So that's what the because this is supposed to be after the midterm, but this is just in case it shows up. This is something that the geometry you just haven't gotten to yet. What do those arrows mean? The arrows that you see, yeah, it means parallel. When you have parallel segments inside of a triangle, that means that you have similar triangles. Those triangles are similar by angle-angle similarity. We'll get into that in the next week after midterms. So when you have similar triangles, and the angles are congruent, like the one that we saw before today. The angles have a corresponding angle that matches. But the sides are not congruent, they're actually proportional. What I would advise you to do is to split these two up. They want to know SE, which SE is part of the smaller triangle. This is 20, this is 22, and then SE is what we're trying to find. Then the bigger triangle, SUT, they tell us that this is 25, the bottom is 55, and then this entire side is 50. If you don't know how to do it, that's fine. I am not under the impression that you've gone over this, but just in case it shows up on the midterm. So what you need to do here is first figure out what the scale factor is. You saw how, like on the dilation, there was a scale factor. That's what's happening on similar triangles. Is you either have an enlargement or a reduction. So we have to figure out a pair of corresponding sides that we know both of. In this case, they give us 2, so pick one. Like, what does the SF correspond to? What does it correspond to? ST. And since I know both measurements, I could use that as a scale factor if I want. I also know EF and UT. I could use that if I want to, but you have to pick a pair of corresponding sides where you know both measurements. I can't use the SE yet because I don't know what SE is. I'll just go, I like numbers that end in 0, so I'll use 20 over 50 as my scale factor. That's going to be my fraction. Corresponding sides are proportional. What is a proportion? It's an equation that has 2 equal fractions. I just got to figure out what goes on the other fraction. The 20, did it come from the big triangle or the little triangle? The little one. The SE that I'm trying to find, is it part of the big triangle or the little triangle? SE is part of the little one. So I need to make sure that the SE is lined up with the other measurement that came from the same triangle. So I'm going to put the SE on top. If the SE would have been part of the bigger triangle, I'd put it on the bottom. I want to make sure it's lined up. Now, which side corresponds to SE? SU, and how long is SU? 25. That would be the new part. Once you have it written, then you should know how to solve a proportion either from last year or, I guess from last year. Algebra 1. How do you solve a proportion?
Cross multiply.
Cross multiply, good. So 50 times SE is equal to 20 times 25. 50 times SE is equal to 500. Divide by 50. SE is equal to so I would advise you there when you have overlapping triangles to separate them, draw them separately. Any questions on that one? Mohammed, you okay back there? Draw the mid-segment between AB and BC. Use the appropriate. Okay, this will take 2 seconds. How would you construct a mid-segment? What do you call a point in the middle of a segment? Hillary? The point, a midpoint. So you would put the midpoint of AB. They did say to call it DF, so let's call this D, and the way you would mark it is to say that those two are the same. Then you would have the midpoint of BC, which we'll call it F. Now those two are also the same, but they're not necessarily the same as the segments on the other side, so I would use 2 slashes. That's all we were asked to do. Ooh. I mean, I'm just looking at this right now. See if you can read my mind. What's the first thing that's coming to my mind? What? There's a bunch of variables going on there, a bunch of expressions. I can see they're talking about triangles.
Draw a picture.
Yeah, I'd draw a picture. I would definitely draw a picture. So they give me a triangle called JKL and another triangle called MNP, which are supposed to be congruent. So I'll put M, then N would go with where the K is, and P would be there, and then I would label. So KL is 21x minus 2. NP is 20x. LJ is 15x. PM is 13x plus 4. And find LJ. See, now here, these triangles are not similar, they're actually congruent. So sides are not proportional. I don't have to write a proportion. I can just make the corresponding sides equal to each other. So 15, LJ is 15x. What is 15x going to be equal to? MP, which is 13x plus 4. All the other information which is given to you that was just extra, just like what they call a distractor to throw you off. So x is 2. But always go back and check what the question was asking you. It wasn't asking you for x, it was asking you for LJ. LJ was 15x.
30.
So I would say LJ is 15 times 2, which is 30. What additional information is needed to prove these triangles congruent by side, side, side? So they're telling us what shortcut we would need. They've already told us that side EV is congruent to TU. So side TV would have to be congruent to itself. Usually they'll write it like that, like backwards. What property allows us to say that something is congruent to itself? reflexive, yeah. And then the only other one that's left would be that each side ET is congruent to V. Now we don't necessarily have enough information to prove that, but they just ask if we were gonna have to use side, 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 this is what we would have to somehow be able to prove. Yeah.
Does that have to be, can it be VU or should it be VU?
Doesn't really matter. You want to do, oh, that's true. That's because you're saying that E corresponds to U. It doesn't matter. I mean, they're both because they're congruent. So if they're the same, it doesn't matter what order you put in. You're fine. Better off that way. Any other questions? What is the reason why these two triangles are congruent? Well, in order to use a well, in order to use hypotenuse leg, they'd have to tell you that the hypotenuses were congruent. So, can't use hypotenuse leg.
Angle, side.
But wait, how can you say angle, angle, side? I only see one angle. Go ahead, Scotty.
Vertical.
Yeah, vertical angles. So this angle has to be the same as this angle here because of the vertical. So this would be angle, angle, side if you go in order. Angle, angle, side. Angle, angle, side. Angle. Sometimes you might see that as side angle, angle. Same thing. Any questions there? The car you're hiding out back there, are you okay? Yeah. Alright. This is the one I was talking about. This is almost identical to what you saw yesterday on the test. If A and B are midpoints, what type of a segment is AB? If A and B are midpoints, what type of a segment is? It's a mid-segment. Huh? You're missing that sheet?
Yeah, that one says number 12. This is
Well, I skipped some. Do you have number 12 on the paper?
yeah.
Yeah, I tried, like, most of them are there, but there's certain ones I wanted to focus on. So, what do we know about the mid-segment? You can say the mid-segment is half the third side, which is 34, or you can say that two mid-segments give you the third side. Hattie, I haven't heard from you today, so I'll let you pick. Which one do you want to solve? They'll give you the same answer. You want to solve the red one or the blue one? Okay, blue sounds good. You could just divide by 2 if you wanted to, but I would guess most of you would probably distribute. So I would say 6x minus 2 is equal to 34, plus 2 plus 2, 6x equals 36. Divide by 6, x equals 6. But now we got to see what they wanted. They wanted both x and AB. So now that I know that x is 6, AB would just be 3 times that 6 minus 1. Yeah. Mickey, did I have to do that in order to find out what AB was?
No.
How could I have found AB even before I found x? No plugging.
34 divided by 2.
Yeah, if the mid-segment is half the third side and they told me the third side is 34, what's half of 34? 17. Yeah, you didn't really have to do that. Baby, any questions? Kenny, how about you? Okay, proofs. Let's prove that these two triangles are the same. So let's see, they tell me first that, here, let's do statements. Do a two-column proof and reasons. So they tell me that statement 1 is that Jn bisects ML. And that's given then they tell me that angle M is congruent to angle L, and that's also given. Okay, so if JN is cutting ML in half, that means that JK is the same thing as KN. So I could then say my next statement, that segment, right, JN, or did I do it backwards? I did it backwards. JN bisects, ML is what's getting cut in half. So here we go. Those two are the same. So, therefore segment MK would be congruent to segment KL. What would be the reason for that?
Angle side.
No, I got to the triangle part yet.
Reflexive?
No. What allowed me to make this statement?
Oh,
Definition of bisector.
Good. Definition of a bisector. What would be the last statement I would need before I can prove the congruency?
Vertical angles.
Okay, so yes, you're right. We do have vertical angles, but that vertical angles is a reason. And actually you would say vertical angles are congruent, but the statement would be that the that angle JKM is congruent to angle
LK.
well, let's see, if you wanted to go, you don't have to go in order, but if you wanted to go in order, you said NKL?
I said LK.
Yeah, it's fine. Like it's not wrong, but if you wanna be like precise with the order, like with the corresponding points, the end would come first, NKL. But if you put LK at that point, that's fine. Where it would be wrong is, okay, now we do have enough, so we can go ahead and make our statement. You got to make sure that it looks exactly like this. Triangle MJK is congruent to triangle LMK. And what's the reason for that now? It's not side angle side.
Oh, angle side.
Yeah, angle side angle. Angle side angle congruency. Let's get this next proof, because proofs take a little bit long. I want to try to get as much done today before we leave, so I'll just skip this one for now. We did one proof already. I'll do one of these. We already did one, but just set for the second time today. How do you solve it? Here they already, instead of having to write the proportion, they give you the proportion. How do you solve a proportion? Cross multiply. If two fractions are equal, their cross products are equal. So I could say that 5 times r is equal to 3. This is why I'm doing this one also, because when it has two terms, the last one I don't believe had two terms, make sure you put it in parentheses. So 5r is equal to 3r plus 9, minus 3r minus 3r, 2r is equal to 9. If you divide by 2, I always like to leave improper fractions. If I can't divide 9 by 2. So I prefer to leave it improper, but some of you are in love with decimals. If you put 4.5, that's fine. Just make sure you're not rounding. Luckily, 9 divided by 2 is exactly 4.5. So if you put it as a decimal on any platform, it should be more correct. But just be careful you're not rounding. If that would have been like 9 divided by 7, you have to round. So Thornton's at what, at 16?
Yeah.
Okay, transformations. X, Y, Z is transformed. So draw the pre-image, the image, and then identify the transformation. Okay, this is number 16. So X is at 3, negative 3. Y is at 1, negative 2. And then Z is at 3, 0. Now x prime is at -3, -3. Y prime is at -1, -2. And then z prime is at -3, 0. So compare the image and the pre-image. What type of transformation does it appear occurred? It does appear like a reflection because look at the corresponding points.
It's the opposite.
Yeah, y corresponds with y, and they're both 1 unit away from the y-axis. Z corresponds with z, and they're both 3 units away from the y-axis. And the same thing with the x. It doesn't appear that the triangle has changed shape, so no dilation has occurred. So this would be a reflection, and if you wanted to be more specific, what type of reflection? Over the y-axis. Good. Hillary, you got that? Oh, your favorites. What type of angles are those? Vertical angles. The vertical angles are? Congruent. 11x plus 11 is equal to 110. Minus 11 minus 11. 11x is equal to 99. Yeah. And then you are correct. Correct, Scotty. That x is 9. I'll do one more after this one, and then this is not. I'm not going to collect this. This was just for review. If you want to do this on your own, anytime from now till Friday, I'll be here before school like I normally am. And this week, since basketball doesn't really start until next week, I'll be here after school for a little bit too each day. Oh, this one's in here. Okay, well, this one doesn't count. I'll do one more after this one. What does CTC stand for?
I forgot.
Honestly, you remember?
CPC and CQ.
No, corresponding.
Oh, corresponding parts of congruent triangle.
Good, corresponding parts. And then there's a little of here, which we don't really mention. Corresponding parts of congruent triangles. And then there's like another little R. Congruent. That's an easy one too. 1.5 pound through. Is it just angle relationships? Okay, yeah, perfect. Let's do this one. This one I remember we struggled with on the triangle one.
Yeah.
What type of angle is this over here?
Exterior.
Exterior on a triangle. The exterior angle is equal to the sum of the two interior angles that it does not touch, which can mean they're giving you both of them. So 2x plus 20 plus 40. So 3x plus 10 is equal to 2x plus 60. Minus 2x minus 2x minus 10 minus 10. So x is equal to 50. I recorded this. I'll post it tonight. If you want to do the packet on your own to practice for the midterm, you can. Oh, another thing to point out before you leave, this one you're going to want to listen to. So, see, this is something I'm doing on my own.